Finding life beyond, extending life there, improving life here. Inspiring the next generation of explorers as only NASA can. Our vision of the future is extended by the capability of information and instrument systems technology developed by NASA's Earth Science Technology Office, known as ESTO, to observe global changes and to provide knowledge, solutions, and educational opportunities for future generations. For example, viewing urban nightlights from the vantage point of satellites enables us to understand the relationship between urban growth and economic development. During storms, Sentinel satellite drones in low Earth orbits use lightweight rainfall radiometers to facilitate the prediction of weather and global climate change. A remote sensing instrument that measures water vapor and cloud liquid profiles is a passive microwave high-altitude atmospheric sounder known as HAMSR. Light detection and ranging instruments, or LiDAR, use active sensing technology to measure wind speeds with lasers. Data mining tools facilitate hurricane predictions. The data is gathered from low Earth orbit satellites that circle the globe in 3 to 6 hours. Holographic memory and advanced information technology enable the organizing, analyzing, and storing of information about land, oceans, and weather into intelligent products before it is sent to data users on the ground or to other sensors. The Distributed Image Spreadsheet, or DIS, which is in operation over wide area networks, is used as an effective interactive access to large amounts of data imagery. A soil moisture instrument that flies on NASA's DC-8 airplane is the Raman Airborne Spectroscopic LiDAR. This instrument measures water vapor on an order of magnitude better than the current state-of-the-art. The large aperture mesh antenna uses multi-channel feed horns to provide global coverage in 48 hours. This passive microwave 6-meter instrument, when deployed, rotates 6 times per minute and provides high-resolution imaging of the Earth's surface, detecting levels of soil moisture and flooding. One of NASA's solutions for information exchange between satellites and the ground is based on Internet standard architectures and technologies. NASA is taking advantage of GPS technologies to provide onboard navigation in orbit and altitude determination. From the vantage point of near-Earth orbit, NASA technology enables decision makers to manage vegetation resources. The low-power transceiver technology, or LPT, is a modular multi-channel communication unit leveraging high-speed digital signal processing to achieve favorable size, weight, and power consumption characteristics. The LPT is an enabling technology for the sensor web architecture with multifunction communication. Synthetic aperture radiometers can be used for rainfall detection and are ultra-stable for future sea surface salinity missions. The Airborne Laser-Induced Fluorescence Transient Technology, or LIFT, provides measurements of photosynthetic productivity in ecosystems. It uses diode lasers and a camera to capture views of healthy vegetation. Using diode laser-induced fluorescence through a telescope, we're able to use this information to improve how we manage our vegetation. The Gazetteer is an advanced information system technology that enables search, access, analysis, and display of Earth science data. This system is used as a thesaurus of reference terminology for real-time search. Globally accessible sensor web data, communicated through a pod device, provides ground truth for missions that require a virtual presence to monitor the environment, such as biosignatures and carbon cycle changes. An instrument called the Micro Laser Altimeter could be placed on both the shuttle and a satellite as a high repetition rate laser that is hooked up to a photon counting detector, a scanner, and video camera. Hyperspectral image products transferred to handheld palm devices provide ground truthing, calibration in instruments, and validation activities for researchers in the field, working with real-time Earth monitoring systems. NASA's atmospheric and climate research is needed to expand our understanding of atmospheric composition and chemistry and enable our prediction of future changes in ozone, surface ultraviolet radiation, and global pollution. The gas chromatograph mass spectrometer, called Panther, used a four-head pump on the Trans-Siberian Railroad to measure trace gases. GAMS is a refined instrument sensor that flies on the Boeing 757 and DC-8 airplanes. This passive miniature spectrometer enables the capture of atmospheric absorption features of solar radiation. The double-pulse 2-micron laser is a multiple LiDAR active optical instrument that is safe for the eyes and uses conduction cooling. Interferometers measure column levels of carbon dioxide by analyzing spectral absorption of sunlight. They also detect ozone, trace gases, and tropospheric chemistry. Examination of the profile of the global carbon cycle yields important information about precipitation rates, tropospheric winds, and climate variability. One of NASA's innovative solutions to identifying data about global change is the Global Change Master Directory, or GCMD. This provides object-oriented models to handle Earth science search and retrieval services. NASA's active microwave airborne measurements are used in flights over Greenland, open oceans, and ice sheets. The D2P radar altimeter is a new generation of radar that uses advanced Doppler, phase processing, and pulse compression. The Quantum Well Infrared Photodetector Imaging Array, called QUIP, was recognized in 2002 by the National Science Foundation for its many benefits to society's quality of life. For example, thermal infrared imaging measures the presence of angiogenesis in microcirculation. This sensitive instrument facilitates first-phase screening and reliable diagnosis of the depth, size, and shape of tumors. NASA's computational technology, or CT, enables the science community to make production-ready, high-performance applications that model, analyze, and interpret observational mission data. CT enhances our understanding and ability to predict the dynamic interaction of physical, chemical, and biological processes affecting Earth. Science models assimilate and process information data to construct predictions of flood, harvest, forest, transportation, and economic information for business and government planning. The NASA Earth Science Technology Office, ESTO, ensures that new technologies are available for future mission infusion. We invest in technologies that produce significant cost savings and performance enhancements in high-priority science areas. NASA technology enables the understanding and protection of our home planet. NASA's Earth Science Technology enables our ability to search for ways to improve the quality of life right where we live.